In this session we shall see the processing of total station survey data for measurement of quantity or volume of the excavated material. As the main screen opens, use File menu to select Set Working Folder. Next, select Folder Work located on the desktop. Select Menu Item File, then New/Open Project Workspace. Next select Mining Applications and finally select New/Open Stockpile Quantity Measurement. Create Project. As the workspace opens, the current selected tab is Create Project. Selected survey data type is Total Station. For processing users' data, user needs to click on button Create Project under New Project. The new project is created as Design Job Number 01 inside the project folder created inside the working folder as Work, Mining Applications, Opencast Excavation, Design Job Number 01. Next, user needs to click on button Browse to select the user's total station survey data file. After selecting, a copy of the file will be brought into project folder Design Job Number 1 to process. For processing tutorial example data, user needs to click on button Open Tutorial Example Data. The new project is created as Tutorial Opencast Excavation inside the project folder created inside the working folder as Work, Mining Applications, Opencast Excavation, Tutorial Opencast Excavation. Here user need not click on button Browse, as a copy of the total station survey data file survey.txt will be brought into project folder Tutorial Opencast Excavation to process. Under New Project, the survey data file is shown with the path. Ground modeling. The data in the total station survey or by downloading from satellite by using internet with program Global Mapper must be made available in the following format and saved as a text file, for example survey.txt, which can be opened in Notepad. It has 5 columns of data. When a data record with serial number 0 is met, then it discontinues the last feature and reads a new feature in the ground model. The above data may be either in Surveyor's Transverse Marcator, TM, coordinates or in Universal Transverse Marcator, UTM, coordinates. If the data is in TM coordinates, then these are to be converted into UTM coordinates by using GPS UTM coordinates on points with TM coordinates. Next, select the tab Survey Data. Under this tab another tab Ground Modeling is opened. No check mark is put for option UTM, Universal Transverse Marcator, Data Conversion. Click on button Create Ground Model. The message comes, click on button OK. The names of all the survey features are listed in left bottom panel of the project workspace, as shown below. We click in the color box of a feature and we select the desired color for each feature. Click on button Apply and the color is set for the feature. User can remove the check mark from a feature, if we want to deselect the feature, to exclude it from the drawing of the ground model. Next, click on button Draw at the bottom of the left panel of the workspace. By digital mapping, the features are drawn with the selected color. On right side CAD window, we can save the drawing of the ground model either as DWG or DXF, but in unauthorized version any saving of drawing file is not possible. Triangulation. Select tab Triangulation. Select all the survey features by clicking on button Select All. Next, click on button Create Triangulation Model. The dialog box comes to start the process. Click on button Proceed to process for triangulation. As the process is over, the message comes, click on button OK. The files hds001.fill, hds000.fill and contour.fill are created in the project folder. Contours. Select tab Contour. The model name, string label, and increments for primary, secondary and text are set with default names and values. If the ground is of flat nature, then user has to reduce the primary contour increment as 0.1 or 0.2 to get contours for the relatively flat ground. The secondary contour increment is always 5 times of increment of the primary contours. Texts for contour elevations are displayed on the secondary contours. Click on button Create Contour Model. The dialog box comes to start the process. Click on button Run. As the contour window opens, primary C001, secondary C005 and elevation text ELEV strings under model contour are created. Click on button Save, located at the top bar. As the contours are created and displayed, select yellow color icon for contour from bottom bar of the screen as shown and click on button Quit to close the contour window. Next, we are back to the workspace once again. Click on button Draw Contour Model, to draw the contour model and the contours are displayed. Measurement of Opencast excavation quantity. Select tab page Opencast excavation measurement. Click on button Proceed, the message comes. Click on button OK. Next, click the left mouse button outside at two diagonally opposite corners, and the capacity of the excavated pit is displayed on the left side panel of the workspace. The area of horizontal plane is computed at topmost elevation, and there is no quantity is estimated at this topmost elevation. Next, the area is computed for the horizontal plane at next lower elevation, and the quantity is estimated as the average of the previous and the current areas and by multiplying by their difference of elevations. Every time the current volume and the cumulative volume are computed and written in the report. This process is continued up to the lowest elevation of the reservoir. At this lowest point the cumulative volume gives the volume for the excavated pit under consideration. The report is also opened in Notepad. This helps in taking printout of the report. The difference between two volumes made by obtaining survey data, or Datalite downloaded data, at certain interval of time gives the volume of excavation during that period. This is the end of the session for processing of total station survey data for measurement of quantity or volume of the excavated material.